Hi everyone, welcome back. Today I'll be starting a new series where I build my very own Gophercises, updated and improved for 2024. For our first exercise, we'll be building a command line application to play Hangman. In case you're new to my channel, I'm a software engineer in Silicon Valley and I specialize in Go. Now let's get started. Here are the basic rules. First, we need a way to read the data to get categories and words to guess. For that, let's create a new data folder and copy some text files for the random words. Here I have created some animals text files and one for cities. Now let's process the data. As part of the Gophercises, I will introduce some common libraries and packages for you to build our mini application. So, let's read the files that we have just created. We'll use the OS library to read the data folder and remember to check and handle the error. Then, let's get the categories. Now, these would be just the name of the file. Let's add some logging to help us debug if anything goes wrong. Here, we want to create a map of the category to the words. Now, as part of this process, we'll also cover the basic data structures that Golang has, and if you're interested to find out more, I also have a series for leetcode videos where you can do some easy exercises to get familiar with the Golang syntax. Now that we have read the data, let's process the file to actually extract out the information. For that, let's loop through the range of files in our data folder, where first we want to get the category, which is based off the file name. So we can use the strings package to trim suffix from the file name to basically exclude the txt extension. Then we want to get the file path, which we can use the sprintf function to format our strings. So it will follow the first data folder and then file name format. Then we want to read the content of the file, which will use the os.readFile function to read the file content, passing in our file path. Now, it's important to note that this actually reads the file into memory, so we're assuming that the file is not too large. We'll also cover reading large files efficiently in a separate video, so subscribe if you want more Gophercises. Now let's error handle, whereby if there is an error, so we have failed to read the file, but we don't want to kill our program immediately. Instead, we'll just skip it and continue into the next file, because that just means that we're not able to read the category and extract out the words for this specific file, but it should not stop us from processing the other files. Now, at this point, everything is successful, so we can get the words to guess by using again the strings package and the split function to basically split our content based off a new line. Then we can initialize our Hangman data map to set the category key to words value. And we want to append this category to our list of categories. Now, after processing the file, if the length of our map is 0, So there are no keys or categories in our map. That means we have, for some reason, encountered an error for every single one of the files that we have tried to process. So if that's the case, we want to print an error and return our main function. Now for our next part, we want to ask our user to select a category. So for that, we need to store the user category choice in a string and read our user input, which will use the scan new line function, and read it into our category choice string. So let's make sure to just do some sanity checks to change it all to lowercase. And if at this point it was empty, then by default we'll just make it the first category in our list of categories. And we want to add some debug statements so our user knows what is happening. Now we need to select the target word. So first we want to check the available words to choose from using our Hangman data map, and then get a target, which over here we are going to use the inbuilt math standard library in Go to randomly pick an integer out of the available length of words that we have. Then in order to select the word, we choose this integer from the words slice, and then to finally just convert that using the strings to upper function so that we can get it all in uppercase. Next, for the core logic of this part, I will be stepping through the code with a visual as well, so hang in there to understand what is going on here. First, we create a blanks slice, which basically would just keep track of what the guess has been so far based on the length of our target word. Then we are also going to create a letter to indices map. Now what this would do would be basically a map of the character to the indices that they're at. So for example, if we have the letter DEER for the guess deer, then ultimately what we want this map to store would be the letter D at the index 0, letter E at the index 1 and 2, and finally R at the third index. So with that, let's code out the logic. So let's iterate through the characters in our target word. And if the current character is a space, then we want to make sure that our blanks at that index I is also a space. Otherwise, let's initialize our blanks to an underscore to just mimic what we have over here. And now let's convert that character to a string and initialize our letter to indices map, setting the key to this letter. Now if this key does not exist, so if it's not okay, then we want to create our indices slice. So let us go ahead and do that. And we want to append the current index to the slice of indices we have just created, making sure to update our map with this value. So this initializes our blanks and letter to indices map. And now we're ready to start the game. So I initialize the number of lives to the minimum of either the length of the word or 9, because it takes like 9 strokes, 1, 2, 3, 4, 5, 6, 7, 8, 9 to complete our Hangman. So that's just what we'll be dealing with. Now, at first, we want to print out some prompts for our user. So the number of remaining lives as well as the blanks array that we have created before, to just show the user what is the target word length that they're dealing with, as well as a prompt for the user to enter the letter. Now what we want to do is just like before, where we have read our category choice from the user using the scan line function. We want to do the same. So we have an input letter and then we read the user's input letter and clean it up to uppercase. Now let me quickly reset this so we understand what's going on when user makes a guess. For example, if the guess was the letter E, then we're going to check this map that we have created, and for each value in the indices slice, we are going to populate the blanks array with the letter E. The code for this part would look like: if the input letter exists in our map, then it means that the guess is correct. And for each index in our list, we need to update our blanks slice to set the index to the input letter that has been guessed. Now, if the guess is not correct, then we need to decrease the number of lives. Finally, all that's left is to handle the winning and losing scenarios. So if the number of lives is less than 0, then of course the player has lost. But if we were to join our blanks slice and it matches the target word, then the user has successfully guessed and won the game. There we go. Now let's run this program and put it to the test. Thanks for watching. If you like this video, please subscribe to my channel for more Gophercises, where I'll be covering topics like Go concurrency and building backend projects. See you next time!